Hello everyone, my name is Samantha Barrios. My presentation is on the first ever isolated neutron star to be found outside of our galaxy. If you haven't guessed it by now, the title of the article is called Dead Star Circled by Light, and it was published by the European Southern Observatory. I found the article on astronomy.com and it was published Friday, April 6, 2018. The article discusses the discovery of an isolated neutron star that has been buried in the filaments of a gas from a 2,000-year-old supernova explosion. The supernova remains in which the isolated neutron star was found is known as 1E0102.2-7219, which happens to be in one of our neighboring galaxies, the Small Magellanic Cloud. It was discovered by a team led by Frederick Vaught, and the image right here on the right-hand side of the slide is a picture of the isolated neutron star. Now let's take a closer look at how the team first discovered this neutron star. First, they took into account new data from the MUSE instrument on ESO's Very Large Telescope in Chile. They revealed that a ring of gas in the supernova remnants was expanding slowly. Then they noticed that the ring was on an X-ray source that had remained a mystery for years prior. It was unclear if it was inside or behind the remnant until the discovery of this ring of gas. With the location of the X-ray source, the team used the existing X-ray observation from NASA's Chandra X-ray Observatory to determine that it was an isolated neutron star with a low magnetic field. Now for some quick background information. The Small Magellanic Cloud is a dwarf galaxy approximately 200,000 light-years away from Earth. It is classified as a dwarf galaxy due to its small diameter of only 7,000 light-years. Neutron stars are the ultra-dense cores of massive stars that collapse and undergo supernova explosions. The stars that result in neutron stars after their collapse are usually around 10 to 29 solar masses. Isolated neutron stars undergo a short but violent phase of X-ray emission before they become radio pulsars. 1E0102.2-7219 neutron star is different from most others because it is both a low magnetic field and does not have a star in orbit around it. Its remnant has a high level of oxygen like Cassiopeia A and Puppis A, despite neither of them having been found to have neutron stars. Why I'm interested. I picked this article because of the fact that the discovery was outside of our galaxy. I feel as though most of the time we learn about our galaxy and everything within it, but it's very rarely talked about what exists on the outside of it. I think that learning more about what is around us will definitely help us learn more about our own galaxy as well. The first instrument used was the MUSE instrument on the Very Large Telescope in Chile. The MUSE is an instrument that was installed on Yepen, the fourth unit telescope. The MUSE is an integral field spectrograph, as it allows one to observe the entirety of an astronomical object in one go, and it measures to intensity of light as a function of its color or wavelength for each pixel. The wavelength coverage is 365 to 930 nm, and its spectral resolution ranges from 1700 in the blue to 3400 in the red. It gives astronomers the best ever three-dimensional view of the deep universe. The second instrument that was used in the discovery was the Chandra X-ray Observatory. It consists of 4 pairs of mirrors and a support structure. The mirrors are combined with 4 science instruments to capture and probe the X-rays. The ASIS and the HRC are used to capture the sharp images formed by the mirrors to provide the number, position, energy, and time of arrival of the X-rays. The LETG and the HETGS provide detailed information about the X-ray energy. Basically, the 4 instruments complement each other so they can record and analyze the X-rays from celestial objects with extreme accuracy. It is the world's most powerful X-ray telescope. Its resolution is 8 times greater, and it can detect sources more than 20 times fainter than previous X-ray telescopes. It has the capability of observing clouds of gas so large that it would take the light more than 5 million years to go from one end to the other. Some other discoveries by these instruments include Chandra's discovery of a black hole that has 20 million mph wind, and its discovery of a massive supernova explosion that left a stellar corpse inside out, or wearing its guts on the outside. ESO's MUSE instrument has observed dark matter that seemed to have been interacting with other dark matter, in a way other than through the force of gravity for the first time, and a star in the cluster, NGC 3201, that appears to be orbiting an invisible black hole with about 4 times the mass of the Sun. Despite being believed to be abundant across the universe, Isolated neutron stars are very hard to find because they only shine at X-ray wavelengths. This makes the first discovery of an isolated neutron star outside of the Milky Way galaxy that much more exciting. Future observations of this isolated neutron star should help astronomers understand the origin of this lonely neutron star and possibly find others that we might have overlooked before. In conclusion, the discovery of the isolated neutron star within the small Magellanic Cloud is an important discovery due to it not being only the first of its kind, but because it will hopefully lead to more discovery of its kind. The quiz questions are: why is 1E0102.2-7219's neutron star different from most others of its kind? How were the astronomers able to discover the isolated neutron star? And where was the isolated neutron star found? I hope you found this as interesting as I did. Thank you for watching and have a great day.